Mechanical waves are the types of waves that interact with matter. Just like you interact with matter, you drink water, you walk to school, you pet a dog, you interact with matter because everything is made of matter except for light, but that's a different story. So the two main types of waves, the way we transfer energy through matter, are transverse waves and longitudinal waves. These are often called compressive waves, and I will probably more often say compression wave than longitudinal, because I feel like longitudinal is hard to say, and I like the word compression more. Makes a little bit more sense to me. So anyway, a transverse wave is a wave that causes particles to move perpendicular to the direction of the wave. You can see I made a couple little diagrams to show that, but let me just go through that one more time. So, for example, if we have a wave that is traveling to the right, the word perpendicular, if you've taken geometry, perpendicular, perpendicular means right angle. So what that is going to say is that, here's a right angle. What that means is that the wave, the energy is going to the right. Like, for example, this lady is sending energy this direction, but the rope is going up and down and up and down, right? So even though you're sending the energy this way, the matter of the rope or whatever it is that you're using is going to do this. It's going to go up and down and up and down. So it travels up and down whenever the direction is sideways. The same thing would happen, for example, if you were trying to send, like if you had a rope hanging off something and you wanted to send energy up the rope, and so you gave it a wiggle like this lady is doing here. The same thing would happen because the energy is traveling up. We need to show that the wave is traveling perpendicular. So it's going to end up looking like this. Okay. So a transverse wave is up and down. Longitudinal or compression wave is how waves, this is a different type. These are caused by compression. So we can see that this lady is punching a punching bag. And so what's happening is she is compressing the very first layer of that punching bag, which then compresses the next layer. And that layer compresses the next one and the next one and the next one, trillions of times over until the entire punching bag has effectively been felt that compression radiating out from where she punched it. Compression waves are most often how we actually move objects. When you push on something, okay, let's say this is your force, and you're pushing on a stick, The stick does not really act like a rigid object. It does not travel as one piece. This layer here pushes on this layer, which pushes on that layer, and it kind of acts like a inchworm, and just a really hypersonic fast inchworm. And that's really actually how things move in the universe, is we just compress things, and then they expand back out to their original shape. But it just happens so quickly that we don't even perceive it. But that's how it works. Those are compression waves.